Okay, now we'll be discussing about the factors one by one. First, we'll start with planetary winds. Now, you see, planetary winds has the greatest or the strongest influence on the flow of ocean currents. As I already told you, that planetary wind try to carry the try to carry the ocean water, surface water, okay, to particular direction. So it says that when trade wind that is blowing from east towards the western side, okay, converges at the equator, it also drags seawater towards the western side. So this dragging is due to the friction of wind with the water. So due to the friction of the wind to the water, this trade wind tries to carries the water in this direction along the eastern coast of the say continents. Okay, now coming to next. Now most of the ocean current in various part of the world follow the direction of the prevailing wind. Special example, ocean current in Indian Ocean changes its direction due to change in the direction of monsoon wind. So we have learned about the monsoon mechanism. There we have learned that the direction of the ocean current, direction of the wind changes in particular direction. So this is the direction during the summer season. So when it is blowing from the ocean towards the land, okay, it not only carries the water along with it, it not only picks up the moistures, but along its flow, the ocean water will also flow along the same direction of the wind. Okay, similarly, when it changes its direction from during the winter season from northeast direction, it also carries the water. Let me erase this first. Okay, let us see this. Okay, wind blowing from northeast direction, it also carries ocean water along with it. Okay, so the direction of the ocean water also changes due to change in the direction of the prevailing wind. So prevailing wind plays a very important role in changing the direction of ocean water. Okay, so here coming to next factor, that is temperature. Now how temperature plays a very important role in controlling ocean currents. Now temperature affects the density of the ocean water. Okay, whether the ocean water is more dense or less dense, so it is also governed by the temperature. So warm equatorial water moves towards the pole, and cold water moves near the cold water moves near the polar areas. Being denser and heavier, water moves towards the equator. So this is a very simple concept here, that in that previous explanation I have already told you in that hypothetical diagram that the water from equator moves towards the pole, okay, as it is warmer. Now water from the polar region moves towards the equator as it is more heavier and denser. Okay, so temperature will try to make the ocean water less dense and more dense. So if the temperature is high, then the water becomes less dense, so it will try to move towards the polar region. And in polar areas the temperature is already less, the water becomes more dense. So as if the water becomes dense, it will try to shrink down and it flows below the warm water. So let us see this. This is a cold water flowing in the flowing downwards to the warm current. Okay, so it is flowing from the polar areas towards the equator. It is moving towards the equator, and this current is moving from equator towards the pole. Because it is lighter, so it will move on the surface towards the pole, and this is heavier, so it will move downward, move below the warm water and moves towards the equator. So this is how temperature will try to increase the density of the water, increase or decrease the density of the ocean water. So this is how the temperature controls the movement of ocean water. Coming to next, that is salinity. Now what is salinity? Salinity is the amount of dissolved salt in the sea. Now this amount of salinity also varies from place to place. Okay, some ocean has higher salinity, some oceans or sea has lesser salinity. Okay, so it is generally less in open sea and more in enclosed sea. The sea which is very open, or the oceans which is open, has less salinity because there is mixing, or the mass of water is more, and the mixing of water is also more. Okay, and the enclosed sea has less salinity because there is no mixing of water. For example, here the salinity of Atlantic Ocean is less and than the Mediterranean Sea. Okay, let me show you in the diagram here. So this is Mediterranean Sea here. Okay, this is Africa, and above this is Europe. This is Europe. So in between Europe and Africa there is Mediterranean Sea here down, so has high salinity, whereas the Atlantic Ocean is quite big, larger in size. So what happened, the salinity of the Atlantic Ocean is less. So what I said in this case, the salinity, the sea or ocean which has higher salinity will try to move towards the lesser salinity areas. That means let's see here, this is Mediterranean Sea towards this direction, and this is Atlantic Ocean, has less salinity. So the ocean surface, the ocean that has less salinity, the water of the ocean will moves on the surface toward the region of higher salinity, and the region which has higher salinity, the ocean water will moves below that and moves toward the region of lesser salinity. Okay, so that means the water from the Mediterranean Sea moves below and reached and comes out in the Atlantic Ocean, and the water from the Atlantic Ocean moves towards the Mediterranean Sea. Okay, so this is how salinity will also controls the movement of ocean water. Okay, so due to higher salinity, some amount of water moves below the ocean and comes out somewhere else, and the area which has lesser salinity with it will moves above that and reach to some other region of higher salinity. Okay, so there is a kind of circulation, it moves in this direction, from below it comes again. Okay, so it is a kind of circulation movement, a kind of circulation. So this circulation will try to uh, carry the ocean water, okay, from one place to the another place. So this is how salinity will also cause the movement of ocean current. Now coming to next, rotation of the earth. Now rotation of the earth also plays a very important role here. How? Now we know that earth rotates from west to east, which affect the planetary wind and water as well. Therefore, the circulation of the ocean water is clockwise in the northern hemisphere and anti-clockwise in the southern hemisphere. This is the movement of the generally the wind. Okay, if the wind is moving in the anti-clockwise direction, clockwise direction in the northern hemisphere, then the ocean current will also move in the clockwise direction in the northern hemisphere. Okay, and if it is moving in the anti-clockwise direction in the southern hemisphere, the ocean water will also move in the anti-clockwise direction, because prevailing wind will try to control the movement of the ocean current as well. Okay, now look here, if this wind moves anti-clockwise direction in the northern hemisphere and anti-clockwise direction in the southern hemisphere, so along with the same direction the ocean current will also move. Okay, so the movement of ocean current in the northern hemisphere is clockwise and anti-clockwise in the southern hemisphere. So this is a basic concept. Now coming to next, shape of the land. Now here, shape of the land is also an important factor here. Shape of the land plays an important role in abstraction and diversion of the ocean water. Like in case of this hypothetical diagram we have learned here, the shape of the land is controlling the movement of the ocean current. Here, this wind moving towards this direction is obstructed by this land body, and because of this abstraction this water will bifurcate in the south pole in both the side. The same thing happens in other sectors. If there is any land body, this land body uh, will try to bifurcate, or will try to change the direction of the ocean currents. Okay, now coming to next. Now here, for example, the equatorial ocean current in the North Atlantic is bifurcated into two branches, right? Now look here, Cayenne current to the north and Brazilian current to the south. Okay, this is due to the shape of the coast, Brazilian coast. Now look here, look at this diagram. This is a trade wind, right? So as it blows towards the western direction, it is obstructed by this coast, Brazilian coast. So here, due to this coast, or due to this existence of this land body, what happened is, now you see this wind is changing its direction. One part is moving towards the northern side, this one, and one part is moving toward the southern side because of this land body. So one is that moves toward the northern along the Gulf of Mexico is a Cayenne current, and the one that is moving toward the southern side is a Brazilian current. Okay, so this is how the shape of the land also controls the direction of the ocean currents. Now coming to next, seasonal variation. Now seasonal variation in the direction of the prevailing wind affect the direction of the ocean current, as I already told in case of monsoon. Okay, uh, the direction of the monsoon wind changes. When the direction of the monsoon wind changes, the direction of the ocean current will also change. So example is, ocean current in the northern part of India changes their direction according to the seasonal variation in the monsoon wind. Okay, so changing in the direction of the monsoon wind, or maybe changing in the direction of the other wind, changing in the season, the direction of the wind also changes. Accordingly, the direction of the ocean current will also change. Okay, so up to this we'll be discussing, and rest of the topic will be discussing in the next class, in the next video.